Okay, this is for Algebra 1, and this is day 1 of exponents. And the first thing you need to understand is that an exponent is a small superscripted number that shows how many times a symbol or number is to be multiplied by itself. Okay, it doesn't say that, you might want to add by itself. So for x to the 5th, you've got two parts to this situation. You have a base and you have an exponent. And for x to the 5th, your base is x and your exponent is 5. And you've got to think of it as that, just like anything else, when you have a base, the base is going to hold something else. So your base is the lower part that holds the exponent. If you had 2 to the 4th, your base is the 2 and your exponent is the 4. The 2 is your base, it's down low, and it's holding the 4, your exponent, up high. Okay, so once you're dealing with it, what we're going to look at for one thing today is the law of zero exponents. And this is a very simple law. You just have to memorize it, though. Anything to the 0 power equals 1. So if you have n to the 0 power, it's equal to 1. If you have 3 to the 0 power, it's equal to 1. Because what you have to understand is that, let's just say we had x to the 0 power. Well, when there's not a number in front of the x, its coefficient, you have to understand, is 1. Okay? X to the 0 power means there are no x's, so they're gone. And all that's left is the 1 that was the coefficient for that. So that's why it works that way. You could have 224 to the 0 power, and it equals 1. Anything to the 0 power is 1. Another thing we're going to look at just a little bit today is the law of negative exponents. And basically, we don't want a negative exponent, and we have to fix it. And the way it works when you have a negative exponent is you move to other part of the fraction. Now here's the thing. The only thing that gets moved is whatever had that negative exponent. If it was in the top, you move it to the bottom. If it was in the bottom, you move it to the top. When you move it, the number for the exponent stays the same, but it becomes positive. So if you had n to the negative 3, in order to move it, you got to think of it as a fraction. So think of it as n to the negative 3 over 1. This is going to move to the bottom. So the bottom is now n to the positive 3. The key here is you can't leave the top of your fraction empty, so you put a 1 there just as a placeholder. So 2 to the negative 4, think of that as being over 1. It has to go to the bottom, so it becomes 2 to the positive 4 on the bottom, and you have a 1 on top. We will deal more with negative exponents tomorrow. Okay, so the multiplication law of exponents. First of all, the bases must be equal. What it's saying is the bases have to be the same. Okay, it's just like anything else we've done. You can't combine x's with y's. You can't combine x's with constants. They got to be the same. And then you add the exponent. What you need to understand is that in all of these problems we do in this unit, you will never do to the exponent what the actual problem is doing. If it's a multiplication problem, you will not multiply your exponents. If it's an addition problem, you will not add your exponents, okay? You never, ever, ever do to the exponents what the problem is doing. Now, the coefficients, the big numbers, if you will, at the front, they do what the problem is saying. So, if the base is the same, it stays whatever it was. And you will simply add the exponents. So your base for both of these is x, it stays x, and then you add your exponents, so a plus b. So if you had 2 squared times 2 to the 3rd, remember your base is what's holding the exponents. Is it the same? Yes, your base is 2 in both of those. And then you're going to add your exponents. So you're going to say 2 plus 3 is 5, and your answer is 2 to the 5th. If you had 4 squared times 4 squared, your base has to be the same. It is. Your base is 4. And then you take your exponents, 2 plus 2, and add them. 2 plus 2 is 4. Your base stays whatever it was. X to the 3rd times x to the 5th, your base is x. and then you're going to say 3 plus 5, and so it's x to the 8th. Okay, your base stays the same. Doesn't matter whether it's a variable or a number, and your exponents will get added. So let's look at some. X to the 4th times x to the 3rd. Your base is x, and then you say 4 plus 3 is 7, so x to the 7th. K to the 5th times k to the 6th. Your base is k, stays k. 5 plus 6 is 11. 3m squared times m to the 5th. What we've changed here is we've actually given you a constant. Okay, not a constant, a coefficient, a number in front. Now the coefficient here is 3. There's not one there. When there's not one written, remember it's 1. As I said earlier, whatever the problem is doing is what you do with the coefficients. This is a multiplication problem, so 3 times 1 is still 3. Okay, so it stays 3. Your base stays the base. It doesn't change, so your base is m. And then you add your exponents, so 2 plus 5 is 7. So look at that and make sure you understand where the 3 came from, where the m came from, and where the 7 came from. So on this one, they both have coefficients, so you're going to say 2 times 4, and you're going to get 8. Your base on both of them is x, and you add your exponents, so 3 plus 5 is 8. Negative 3 times 2 is negative 6. N is your base, and 7 plus 2 is 9. Now, how did I know to multiply this one? Because parentheses mean multiply. And if it helps you to understand it a little bit better, you need to put parentheses around that first one. That's fine, because it's like it's 2 sets of parentheses. Negative 3 times negative 2, and once again, when you have all these signs going on, you may want to use your calculator, is a positive 6. Your base is a, and then 4 plus 2 is 6. Okay, on this bottom part, we're not going to do all of them, but we will do some. On number 1, we're not going to do it. Number 2, we are. I think number 1 was marked out probably on your handout. All right, 10 to the 3rd times 10 squared. Your base is 10. And then you're going to say 3 plus 2 is 5. All right, I want you to pause the video for a minute. I want you to attempt number 3. I want you to attempt number 4 without me. Number 5, 6, 7, 8, 9. I know it disappoints you, but we're going to skip them because we're going to save that topic for later in the week. So right now, pause the video and do number 3 and 4, then turn it back on and check your answers. So number 3, your base is x, and then you say 12 plus 15, and you get 27. Number 4, your base, look at that. Tell me about your base. What is your base here? Your base is 4. What is your base here? It's 2. It's not the same. You can't do this, okay? Can't, let's just say combine, because their base is not the same. Okay, and the base, remember, is what holds the exponent. And if it's not the same, you can't do anything. Okay, so now just make room wherever you can on your paper, maybe kind of where we marked out some of these, and let's do a few more. So take a minute, pause the video again, write these 4 problems down at the bottom of your paper, attempt to solve them, then come back and watch the video to see if you did it right. So pause the video and work these 4 problems. Okay, on your first one, your base for all of those is x, and then you say 3 plus negative 2 plus negative 8, and just punch that in your calculator so you don't have to worry about signs. And you're going to get x to the negative 7. Now, we haven't really worked with it, but we talked at the beginning, we don't want a negative exponent. And the way you fix that is you move it to the other part of the fraction. So it becomes 1 over x to the 7th. That's your final answer for that one. All right, the next one, you had to take your coefficients and you had to actually multiply them. So it was 3 times 2 times negative 2. 3 times 2 is 6, times negative 2 is negative 12. Now, if you needed to do that in the calculator, that's fine. Your base is x. You take your exponents at the top and you add them. So it's 5 plus negative 4 plus 5. And when you combine those, you should get a negative 4. Okay, so this one is a little different because it does have a negative exponent that has to be fixed, but there's also something else. Remember, you think of it as being over 1, and the only thing you move is what has that negative exponent. The 12, I know it's a negative number, but it's not a negative exponent, so it's all good. So you leave your negative 12 in the top, and you move your x to the 4th in the bottom. And that is your final answer. This next one, once again, you're multiplying 4 times negative 1/2 times 3. So you're going to get negative 6. Then you're going to add your exponents. So 5 plus negative 2 plus 3. So your base is still x, and your exponent is 6. It's okay for this coefficient at the beginning to be negative. You don't have to move it. That's your answer. Last one on this page, you're going to multiply negative 2 times 4 times negative 5. It's going to become a positive 40. Your base is x. You're going to add your exponents. Okay, now here's another thing that's a little different. This x doesn't have an exponent. If there's not an exponent with it, it's like it's a 1. It's x to the first. So 3 plus 1 plus negative 3 is 1, and so it's just 40x. You do not have to put the 1. Okay, you're going to have to find somewhere to squeeze these problems in as well. You don't have to pause. I want us to work through them together. What I want you to be looking for is anytime you have an exponent of 0. Remember at the first of your notes we said anything to the 0 power is 1. So if you notice, all of this in parentheses is being raised to the 0 power. That means this whole thing is 1, so technically it goes away. That whole thing is just 1. So when we're multiplying, 1 doesn't need to do anything. So you're basically going to say 3 times negative 2 is negative 6. You have a base of x, which has a 1, plus a 1 is 2. You have a base of y with the 1 plus a 1 is 2. So negative 6x squared y squared is your answer. You're going to take negative 2 times 4 and you're going to get negative 8. You have a base of x. This is like 1 plus negative 3, so that is a negative 2. You have a base of y. This is like 1 plus 2, so that is 3. And you have a base of z, and this is the only one that's there, so it's just z. Thing you got to realize here is you've got a negative exponent that has to be fixed. The base, the exponent with the negative exponent is the only thing that moves. So my negative 8 is fine, my y to the third is fine, and my z is fine. My x squared has to move to the bottom. Negative 3 times 2 is negative 6. I have an x to the negative 3 plus 1, which is negative 2. I have a y, and that's the only one there. Once again, you got to fix the negative exponent. It becomes negative 6y over x squared. Negative 5 times negative 3 gives you a positive 15. A to the 2 plus 4 is 6. B to the 1 plus negative 2 is negative 1. And then don't lose that c. You can't have that negative exponent, so it's going to be 15. A to the 6th c over b. When you move it down to the bottom, it becomes just b. Okay, this takes you to your assignment. If you have any questions, you really need to call me over. You will need to turn your notes in with your assignment today. So make sure you've got them all filled out and that you turn in the notes and the assignment. Call me over if you have questions.